in this particular section, we're going to talk about Maven. Now, basically, when you build a project, of course, till this point, we have worked with different code, different syntax, different concept. But then when you build a project, you need more than the syntax and more than the concept. So basically, there's a tool called Maven, which is a project management tool. Now, question arises, why do we need it? Now, think about this. When you build a project, there are certain steps which you have to follow. Example, when you're building a project, you need to compile your files, you need to run your files, you need to test your files, you need to create a package of it, and you need to deploy as well. And normally we can do that with the help of IDEs, right? So that's one thing. Basically, we need all those steps. On the other hand, when you build a project, of course, you write a lot of code to build something, to make it work. But sometimes you need to use some external libraries. Now, what I mean by external libraries, example, let's say if you want to connect your Java code with database, you need a connector. Now, depending upon which DBMS you're working with, you need that particular connector. Example, for MySQL, we need MySQL connector. For Postgres, we need Postgres connector. Let's say if you're working with Hibernate. Now, of course, we have not talked about Hibernate, but let's say there is a framework or tool which helps you to save data in database without writing SQL query. That's what Hibernate is. And then it looks like magical thing. But the thing is, it's just an illusion. Lot of things are happening behind the scene. Now, to make it work, you need to get the libraries for Hibernate. Now, when I say library in Java, we're talking about the jar files. So basically, we have to get those jar files. Now, how will you get it? It's very simple. Just go to Google and search for Hibernate jar files, and then you can just download it and get it to your project. So basically, different IDEs supports adding the jar files to your project. Now, if you're working with JDBC, where you are connecting with, let's say, MySQL, you just need one connector. When it comes to Hibernate, you need multiple jar files because the main dependency which you have is a jar file of Hibernate, but Hibernate itself is dependent on the other jar files. We call them as transitive dependencies. So basically, you need to get all the dependencies, all the jar files in your machine. And you will say, okay, we can do that because we have to do that only once. Technically, yes, you will do that only once at the start of your project. But what if in future you want to upgrade your dependencies? At that point, what you will do is you will again re-download the dependencies. So that's an added work you have to do. Plus, let's say if you're working with some other libraries as well, or other frameworks, let's say if you're working with Spring framework. Now, Spring needs their own dependencies, own jar files. And now, Spring and Hibernate will work together. That also means that the jar files which you have, of course, they will also have their versions. So the Spring will work with Hibernate. So let's say whatever version you're using for Spring should match with the version of Hibernate. So let's say if Spring 5 works with Hibernate 4, there's a chance that Spring 5 will not work with Hibernate 5 or Spring 6 will not work with Hibernate 4. So that means every time you want to upgrade something or make some changes, you need to get the jar files again downloaded. So that's one problem. Second problem is, what if you are giving your project to your colleague for testing or code review, or maybe they want to add something in the project. So we have to make sure that they also have the same dependencies which you have added. So they will also go to Google, they will also download added work, plus they have to make sure they get the right version which you are using. What if they are using some different version? It will not work. And that's where we need to make sure that all the versions are in sync. Plus we want those features as well, right? Which is compiling, running, testing, creating a package, installing, deploying. If you can get a tool which will help you with all these things, and that's where Maven comes into picture. Now, of course, Maven is not the only tool available in the market. There are multiple tools available. Example, we have Maven, we have Gradle, we got Ant with Ivy. So there are a lot of options, but we are going to use Maven, which I feel is beginner friendly. Gradle is great, but I feel that if you are new to project development in Java, Maven will be easier to work with. Of course, when we go ahead in the project, we are going to use Maven there. So in this section, let's understand Maven properly, at least to get started with the Spring framework or any other framework if you're working with. So basically, we have to get Maven, which helps you to get the dependencies. Now, what happens in Maven is, let's say if you want to get dependencies, you can simply say, hey Maven, I need a Hibernate dependency. So let's say this is the name of the Hibernate dependency, and then this is a version. So you can specify that, and Hibernate say, and the Maven says, take it. So that's how it works. Now, of course, once you start working with, I will show you how things are moving and from where you get the dependencies, but that's what Maven is. And plus, for all the phases which we talked about, compiling, testing, running, Maven also provides you some plugins to do that. Okay. So the idea of this section is not to focus more on the plugins. The idea is to work with the dependencies. Maven is a huge concept. So let's focus only for the dependency part. So the first step is, how do you get Maven in your machine? The thing is, you can use Maven as a local tool. So basically you can install Maven, you can just set the path and you can access Maven with the help of command line. But the thing is, we are focusing more on the IDEs now, right? So can we use Maven with IDE? Of course we can, and most of the IDEs provides the Maven support. But if you want to install in your machine, you can just go there. Now this is the official website of Maven. So this is maven.apache.org. Now basically it's an Apache project, so you can explore, you can just go to the website and explore the other things. If you want to download, you can see there's a download option here. Click on download and you can get the Maven from here, and then you can set the path and you can use Maven on the command line. But of course that's not our main intention here. So how we are going to use Maven? So it's very simple. We can use any IDE. So we can use Eclipse, we can use IntelliJ. Now here, I'm going to use IntelliJ. So what I will do is I will just open IntelliJ IDEA, and it also works with the community version or ultimate version. I have both, so I can just use the ultimate version here. And let me create a new project. Now see what happens when you create a new project. So when you click on new project, it will give you a lot of options, right? So here, we can mention the name. I will say this is Maven demo. That's what we are doing here. And I'm keeping this in downloads because I'm going to delete this project after the course. So let's let it be here. And then it will ask you for the language. Now, since IntelliJ supports multiple languages, let's stick to Java here. And then if you look at the build system, now different IDE have their own build systems. And that's one of the issues, right? So example, let's say if you're working with Eclipse and if you're building a web project, all your web content goes into the web content folder. I mean, that makes sense, right? But in IntelliJ, it might have a different folder name. So that means if you are working on a web project using Eclipse, when you give your project to your colleague and they're using on IntelliJ, so it might create some issue. And what if you are using Maven here? So if your build system is Maven, then you don't have to worry, because on both the systems, irrespective of your IDE, the project structure will remain same. So let's select Maven here, and depend upon whichever JDK you have, that perfectly works. Click on create. And you can see by default, we do have a Maven support. Of course, we'll discuss what is happening here in some time, but this is your basic structure. Okay, that's how you get Maven. Now, if you remember, we have talked about the different stages, right, of project. So let's say you write the project, then you compile the files, you test the files, you run the files, lot of steps, right? Now this can be achieved with the help of Maven plugins. Now, if in your IDE, now depending upon which IDE you're using, you will see the option of Maven. In IntelliJ, you will see on the right top. On Eclipse, you might see in different position, you will find it. So click on Maven here. And if you can see, this is my Maven project. But if you can see, there's an option of lifecycle. Now, this is what I was talking about. So let's say I got this very simple code. If I see the main code here, okay, there's no code at this point. Of course, we can create a simple file. But once you create a simple file, and what if you want to compile all those files? You can simply click on compile here, and Maven will take care of it. You don't have to compile it manually and stuff. What if you want to, you have written some test classes here and then you want to test it. So you can just click on test and it will do the work for you. Of course, you can do all those things with the help of command lines, but we can also use the IDE feature. We can create a jar file of your project. So if you can click on package, it will create a jar file here. So if you can see, this is the jar file which is already created. So it goes into this particular path and you can access the jar file, right? So it's so easy to create a package. What if you want to install this? You can do that with install. What if you want to deploy? You can do that with deploy. Of course, for different deployment, you have to configure. That's why you got error here. So that's the life cycle. So this is how you can basically follow the steps. Then we have some plugins. So to achieve all those things, Maven provides their own plugins. So we can use these plugins basically and we can make it work. So that's the Maven here. And yeah, so those are the plugins. And the basic thing is Maven also has something called an archetype. So let's try to see what are those things in the upcoming videos. So before we go ahead, we have to talk about the archetypes. Now Maven provides you something called an archetype, which is a templating tool. So what it does is, let's say you want to build a web project. Now, of course, you can do the setup by yourself. You can add the configuration, or you can use the existing templates. Now that is what is called archetype in Maven. So there are a lot of archetypes available. You can choose them, or you can create your own. So let's say for your project, or maybe in your company, you are going to create multiple projects with the same type. So what you can do is you can create a template. So for this type of project, you will get all the configuration, all the dependencies mentioned, so that whoever wants to build a new project, they can use your template. So that's also possible in Maven. Now going ahead, let's talk about what you can do with Maven. Of course, I've mentioned that you can do all the lifecycle stuff, but also you can handle the dependencies. Now in the term or in the world of Maven, when you talk about dependency, I'm talking about the jar files. So whatever libraries you need, you can get that here. So let's say if you want to connect to a MySQL database, so you need a MySQL connector, right? So the ideal way of doing that is you can just go to Google and you can search for MySQL connector for Java, and then on the official website you can download it. So you can just go here and you can choose the operating system. Okay, so you can go here. So I just click on the second link. So here you can see there's an option of download and you can get the jar file and you can add it in the project. That's one way. But again, as I mentioned, you have to maintain the versions as well. So as you can see, for every connector or every jar file or library, you have to first mention the name of the library, and then the version is also important. And then facing version issues is a big headache, right? So what you can do otherwise is you can go to a very famous website, which is mvnrepository.com. Of course, there are multiple options, but then I prefer to go with this. And here you can search for MySQL connector. And you can see we got the first option here. You can click on this. Now this is where you can download the jar file. Okay, so let's say if you go for this version, you can download the jar file from here as well. But again, we don't want to do that, right? So what's the other option? If you go down, there are multiple options here. We have talked about different options. We have Gradle, we have Ivy, but let me just use Maven here. And it says some dependency here. I don't know how to use it. So let's see where we can use this script here, this XML tags. If you go back to your project, you can see there are multiple folders, and there is one file here which is called pom.xml. Now basically POM here, which is POM, stands for Project Object Model. Now this is where you do everything to handle your Maven. So if you can look here, there's something called a group ID, there's something called an artifact ID, there's something called a version. Now imagine when you package your project. So we have the project, right? And we have done packaging as well. Okay, let me just try that once again. If I go back to lifecycle and if I click on package, just observe what is happening here. So if you see the name, okay, since it is already created, what I will do is, which is not creating once more, I will just clean it. So when you say clean, it will delete all the files. Let's say package now. And now you can see it is created one more time. Look at the name of the jar file it is created. So we got a project name, right? And then we got the version. Okay, so this is the same thing which we have to do here. So you can see we have a project name and we have a version here. So every library goes in three things, which is called GAV, which is group ID, artifact ID, and version. Now when you say group ID, so let's say if I create my own package, if I create my own library, I want to make sure that this library is unique throughout the world. How will you do that? What name you will use for your package or library to make it unique? Even if I use some weird name, there's a chance that in the entire world, someone else might have used the same name. So what you can do is every project or every library will have a group ID as well. Now what is this group ID? This is like a package, but we have to make sure that this is unique. Now how can I make this unique? It's very simple. If I use com.telesco, it's unique because telesco.com, I own it. Right? It's my domain. And we know that in the entire world, your domain names are unique. Just reverse your domain name and you get your group ID. So it also specifies that this particular library belongs to this company or this community. So it belongs to this particular thing, which is com.telesco. And in fact, you can also mention team. So let's say this is belong to Java team. So maybe in my company, I have multiple teams. They make multiple projects. So this belongs to a Java team. So I can say com.telesco.java. And then we got this artifact ID. So what is artifact ID? It's your project name and then the version. Now same thing is applicable for whatever library you download. It will have those three things. Let's verify from MySQL. If you observe here, you can see it says dependency. It also has a group ID, which is com.mysql. It makes it unique. It also has an artifact ID, which is a name, which is MySQL connector J. It also has a version, GAV. It's still here, right? But then where we are going to use it. So basically, if you expand your Maven, let me just shrink this part. You can see we have different tags here. Now this follows XML. So as you can see, the file name itself is XML file. We got all the thing for our project. These are the properties which we have. But here we can add one more dependency or one more tag. Now basically, in your project, you're not just going to have one dependency. You're going to have multiple dependency. So I can put everything in a dependencies tag. So you can see everything goes here. So whatever dependency you have here, you can simply copy it. Otherwise in Maven or MVN repository, when you click on that section, it will automatically copy it. So you can simply go back here and paste and save. That's it. You will get your jar file. I know you're not trusting me because we have not done anything manually. We just pasted it, right? How will you get the jar file? So technically, when you save it, it might not give you the jar file. Example, if you expand your external libraries, you don't have MySQL connector. So what you do is, you can see, you will get something like this. It says reload or load your Maven changes. If you don't see the prompt here, just click on Maven. You will see a refresh button. Just click on refresh or reload and just wait. This is getting downloaded from the internet. And you can see we got MySQL connector. Now this MySQL connector is dependent on this particular jar file. So let me show you that. So if I click on dependencies, you can see our jar file which we wanted is dependent on the Google protobuf. Now this is called a transitive dependency. We don't want it, but MySQL says I want. So I would say, okay, if it's your wish, what I want is MySQL. MySQL wants something else. That's their lookout. I'm just concerned about MySQL. It is there. So this is how basically you work with your jar files or dependencies. But what if you want something else? Let's try. So let's say in this project, I also want Hibernate. I will go back here and search for Hibernate. Now this is the library. It is moved. Basically, we can just have to go here. Okay. So there are different versions. I will go for a stable one. This looks stable, 2.7. And then I will just click this. It will say, you can see it says copied to clipboard. I'll come back here and paste, save. Nothing is happening. You can see external libraries have not changed yet. Now you know what to do. Just go to Maven, click on refresh and see the magic. It will take some time because it is downloading not just one, multiple jar files, and just look at the entire shop here of jar files. What we wanted is Hibernate, but Hibernate says, hey, I have my own dependencies. So if you see the structure now, this is your dependency. This is what you want. But there are transitive dependencies. So Hibernate is dependent on this. Example, we also have a glassfish here. If you expand this, it also dependent upon some other jar files. So that's how basically everything works here. And if you just want a library, just paste it here, say reload, and you will get all the dependencies. And the beauty is, if you want to give this project to someone else, you don't need to send them the jar files. When you give them the POM file, what they will do is they will reload the Maven and they will get all the jar files in their machines. It's that awesome. Now, how this is working behind the scene, that we'll see in the next video. So till this point, we have talked about the POM file, right, which is pom.xml. Now in this, you can mention different stuff. Of course, to configure your Maven, you have to make changes in this file. Now, if you want to create a package, we have to mention certain things, right? So for your own project, if you want to make a jar file, you basically need the group ID, you need artifact ID, you need a version, right? So that's how you can create a jar file, or maybe you can create your own libraries if you want. And then in your project, if you want some dependencies, you have to mention those dependencies here. So we have a dependencies tag in which you can mention multiple dependencies. And it's not limited to one or two dependencies. We can create as many dependencies as you want, or you can have as many dependencies you want. In fact, when you work with Spring Framework, you have to add the Spring dependencies. If you are working with Lombok, you have to add Lombok dependency. So it's not limited, right? So basically you can mention everything here. And then this dependency can depend upon some other dependencies which we have talked about before, which are your transitive dependencies. Apart from this, what if you want to work with some plugins? Of course, you can add an extra tag here for the plugins, and even that works. So you can see you can add a plugins repository, you can mention those things, and you can configure the way you want, how you want it to work. But apart from this, of course, even if you don't mention any plugin, but you're still able to do those things, right? So what is happening is the pom.xml, by default, it will show you certain things which you want to change. But there are more settings to it which is not even visible to you. Okay, so this is not the effective POM. So there's a concept called effective POM, also called a super POM, which is the parent, you can say. So basically, whatever changes you make here is also reflected in the effective POM. So let's say when Maven wants to work with your project, they will not look at the POM file. And I know till this point you're talking about POM file, but they will look at something called effective POM. It will have other configuration as well as the configuration which you have done. But how will you see that? So different IDEs have a different way of showing it. In fact, I started working on Maven using NetBeans IDE way back, and it was having a tab, extra tab for effective POM. We are using IntelliJ here. So again, I will also show you a demo of Eclipse in which we'll try to find how do you get the effective POM. But here, if you're working with IntelliJ, what you do is just right click on your pom.xml, and if you go down, you will see there's an option of Maven, and if you go here, there's an option of show effective POM. When you click on this, it will look like a POM file, but the name is different, and if you see, there are more things to it than what you have added. Of course, there's a dependency, but if you go down, there's something called plugin repository, and that's where you are getting all the plugins by default, even if you have not added them. There are resources as well, plugins, so you can see we have all this plugin to use. So there's a plugin for autorun, there's a plugin for clean, there's a plugin for resources, there's a plugin for jar, for the packages which you do, there's a plugin for compiler. So everything is there by default. Even if you don't mention that in the POM file, it's there. So there's an effective POM which is getting created for every Maven project. So whatever changes you make, don't make changes in the effective POM. You as a developer make changes in the pom.xml. So it will create its effective POM here. So this is called effective POM, or you can say super POM, different names, but same thing. Let's talk about the archetypes. Now, as I mentioned before, basically you can create your own templates, or you can use some existing templates. So let's say if you want to build a Spring project or any framework project where you have to do a lot of configuration by yourself. But what if you think, hey, in this world there are so many developers, they might have worked on some framework. So what if I can get those configuration by default? So of course you will not get everything in the world, but there are certain famous templates which are there available with Maven. We can use them, or you can create your own. So these templates are basically called archetypes. Okay, now how we are going to use it? It's very simple. You can create your own archetype, or let's say let me create a new project. So let's say if you click here, when you go for the new project, you can see there's an option of Maven archetype. So basically you can use some existing archetypes here, and you can give a name here. Maybe we'll say demo Spring project. Of course, we're not going to build Spring project, but let's say if I'm working with Spring, you can see nothing to change here. And then when you go down, there's an option of archetype. So now here, this is where you can basically select what kind of project you're building. So there are multiple options. You can go for J2EE simple. So let's say if you want to build a J2EE project, you can use this. If you just want basic configuration, nothing much, you can go for quick start. If you want to build a web application where you need all those folder structures, you can go for web app. But these are the only options we have. The thing is, if you see our catalog here, by default it is internal catalog. This is something which is there in the plugin itself or the Maven installation itself. But what if you want the archetypes from the internet? Now that's where you can go for the Maven Central. Now Maven Central has multiple archetypes. So it is loading all the archetypes now. It will take some time, and I think it's loaded. If you go down, you can see we got so many options. And I'm sure there might be some external catalogs as well, which will give you more options. Never explore it, because when I make a project, most of the projects are Spring projects, so we get the default configuration with the help of Spring Boot. But let's say you want to use any of this archetype, you can just choose from there. Or maybe even you can search for Spring. Let's say if I want to build for something for Spring Boot MVC, or do we have MVC here? Yeah, so we have Jersey. So let's say if you want to build a REST application, you can select this, and this will give you a default structure. Okay, so if I click on create, let's see what you get here. So it is downloading the dependencies. So what dependency we have here? So you can see it got Spring Boot Starter, it got Web MVC, it got a Jersey so that you can run it. And then we got JDBC as well. And you don't have to add those dependency by yourself, right? It also got you H2. So that's the beauty about this. And since it is downloading the entire repository from the internet, you can see it is taking some time. And you will also see the project structure in some time. At this point, we got main, And you can see we already have some code available here. So we got some configuration. We also got an endpoint to connect with. And what else is downloading? So do we have a test file as well? Yeah, there's a test file as well. So at least you get the basic structure so that you can work on it later. Resources, okay, nothing there. There should be some resource files so that we can configure. Yeah, so you can see we got application.yml if you want to provide some configuration. There's also for log4j. There's some configuration. So you can use this template and build the project. So that's the beauty about using the archetypes. And of course in the Eclipse also we have the same option. You can choose, in fact in Eclipse when you create a Maven project, you can basically choose the archetype on the first page itself. In here we have to go for different steps. So that's the POM file and the entire project we got synced up and you can work on this. So this is the advantage of using archetypes. Now let's see how do you make it work in Eclipse. So we have used IntelliJ till this point and I thought, hey, if you are not comfortable with IntelliJ, what if you want to work with Eclipse? Let's see the same option there. So what I will do is I will open IntelliJ here. So I will open Eclipse here, not IntelliJ. And this is the first page which you see. Of course, you might get different prompts initially, but this is a workspace where you can have multiple projects. Now the font is a bit smaller, so I will try to zoom in there. So if you can see, we have an option of creating a Maven project on the left hand side. If you don't see this option, that's fine. You can just go to File, click on New, and click on the Maven project. I think in Eclipse we have different perspective. So this is for enterprise Java and web developers. Okay, so this is the Eclipse IDE. If you're using the Java developer version, you might not see the option. And even in this, we have different perspectives. So if you can click here, you have to choose a perspective here. So you can see I'm into Java EE, which is by default. Make sure that you are there. And then you can just go to File, click on New, Maven project. And this is what I was talking about. So you can create a simple project by skipping the archetype selection, but by default is unchecked, which means when you go to the next page, it will ask you for the archetypes. And you can see it says retrieving the archetypes here. So it will take some time and it got all the archetypes here. Okay, let me try Java EE archetype. But can I go with the group ID? Does it look good? Okay, so let me go with this one, which is only MVC archetype. Let's try. And we can give a name. So this is for our project. I will say com.telisco. Artifact ID is demo MVC project. Okay, the version snapshot because this is the first time we are doing it. So let's click on finish. Now when you click on finish, of course it will take some time to download. It is downloading the archetype or the project structure. So yes, I want to go with this package, build, finish. Where's my project? I'm waiting for it. Yeah, it's there. On the left hand side, if you can see, so this is what you got by default. Of course, the Eclipse looks a bit different compared to IntelliJ. So if you can see, we got project and we got some files as well. So if I go to controller, since in MVC, Spring MVC, we do create controllers and you got the default code. So yes, we can do that here. What about the POM file? Can I add my own dependencies? Of course you can. You can just go here and you can add the dependencies. So this was I was talking about. So in Eclipse also you get this effective POM here. When you click on this, you will see the effective POM. So of course, doesn't matter which IDE you're going to use. If you're using Maven, the structure will be same or the way you work with the Maven will remain same. So yeah, that's it from this. In fact, it also gives you hierarchy. The transitive dependency we talked about. This is the main dependencies which you have. And yeah, that's it. This is the overall structure. Cool. So that's how basically you use Maven in Eclipse. Now let's understand how Maven works behind the scene. Of course, it's not required to know the concept, but what if you get stuck somewhere? Because sometimes you will get a dependencies issue, you will have some version issue, and then at that point you need to know how do you resolve it. It will be easier for you to resolve if you understand what is happening behind the scene. So let's understand this. And the focus is mostly for the dependencies, not for the plugins. So here let's talk about how Maven works to resolve the dependencies. Now what happens is, for every project, when you go to your pom.xml and when you add the dependencies, what happens is, you are asking Maven, hey, Maven, I want these dependencies from the internet. So it says, hey Maven, I need these dependencies. But question arises, how Maven will know from where to get these dependencies? Does it mean that the moment you install Maven on your machine, you will get all the dependencies all over the world in your machine? Of course not, right? It will make your machines very bulky. And even if you have 10 TB hard drive, I think it will not be enough because a lot of libraries are available in the world. So what happens is when you say, hey Maven, I want these dependencies, Maven says, okay, give me some time. I will give you this file. So what it does is, it first search for the file in your local machine, but where? So basically, every Maven or every machine when you have a Maven installed will have something called a M2 folder. Okay, so in your local drive, in your machine basically, if you're using Mac or Windows, if you're using Windows, search for the M2 folder, it should be somewhere else. In Mac, it basically is in your home folder. It's just that it is hidden folder. So you can use Command Shift dot to view all the hidden folders. In Windows, it should be in the documents. Just search for it. So basically in the M2 folder, you will see this option of repository. Now, in my machine, I have all these folders, but if you're using Maven for the first time, you will not have any folder here. So what happened is every time you use Maven to get some dependencies, Maven will have a copy of it inside your local machine. So example, if I delete all these dependencies here, I'm a bit scared to do that because there might be some dependencies which is getting used by some of my projects, but that's fine. I will re-download them. So if I move this to bin, you can see these are empty now. So what was happening is every time I was saying, hey Maven, I need this dependency, Maven was like, okay, let me search that thing in the local machine first, in the M2 folder. If it is there, that's great. What if it is not there? In that case, it goes to the Maven Central, and from there it downloads a dependency. It's that simple. And next time when you want to use it, you have a copy of it in your local machine. So example, if I look at this project now and if I refresh, I think, yeah. So you can see all the dependencies gone is because we have deleted everything. And now if I can refresh this, then it will start downloading dependency again. So that's how basically it works. So when you say, hey Maven, I need a dependency, Maven says, okay, let me check in the local folder. If it is not there, I will go to the remote repository. But there's only one little problem here. The problem is, if you say you have a library on the Maven repository or any central repository, do you think all the libraries are safe? Because if they're not safe, basically your project is not safe. So you have to make sure that you're using only the library which are safe. In fact, in IntelliJ, it gives you a warning. If you can see, it says dependency Maven, this particular version is vulnerable. So basically, most of the libraries which you use are vulnerable, and that's why you get updates for it. So make sure that this version is updated. So there might be some issue with their version here. So what you can do is you can go to Maven repository again, and when you search for S2 database on the Maven repository, if you go here, it will also mention which are vulnerable. So you can see this version is vulnerable. So what you can do is you can simply update your version. You can copy this from here and replace this. So now what you're doing is you're making sure that you're using a safe version. Okay. Now, is it really safe? The thing is, maybe it is not tested properly or there's no bugs found yet. But in future it might. So most of the companies, if they have security as their first priority, so what they will do is they will not be directly connecting with the remote repository. They will have one more layer in between, which is company-wide repository. So company will also have their own repository, and only those libraries are there which are well tested. So basically when you, as a developer, when you say, hey, I want this dependency, Maven will say, okay, let me check that in the local first. If it is not there, I will check for the company repository. Okay. And then if it is there, that's great. If it is not there, then you can't use it. Then at that point, you can request to your security team by saying, hey, I want this dependency. Please get it from the remote repository. And then if it is secure, please add it to your company-wide repository. Yeah, that's how basically Maven works. And if you find any issue with the versions, sometime you get the dependency in your local, and then when you try to use it, it's not working. At that point, just go to M2 folder and delete the file. That's the best solution. So yeah, that's it from Maven. I hope you enjoyed this series. It's like a crash course of Maven. See you in the next video.